Okay, now we talked about cut, we talked about tr. I want to talk about some more commands that are super useful. Again, these are not bash specific, these are just commands on your operating system, but it'd be hard to do a bash course without talking about these commands because they are super useful. Again, I'll be talking about more advanced topics in bash where we won't need these commands, but you should at least be aware of them. If no one's taught you them before, hey, I'm glad I could be the first. If you've seen these before, you're not upset because you know how powerful these tools are. I would never get sick of hearing about them. They are that useful of tooling. So yeah, in order to get started here, we're going to do something very fun here. We are on my Mac, but for this example, I don't want to be on my Mac. I want to be on Linux because this file is going to be easier to parse. So I'm going to SSH into my machine. The machine's name is void. It also happens to be running void Linux. So now we're on a Linux virtual machine that I have that's downstairs in my house right now. So the reason we're doing this is because we can look at a file, etc password. So let's go ahead and look at this file. And I wanted to be on my Mac, or on Linux specifically, because my Mac has like so many entries in this. This has very few entries. It's way easier to parse and way easier to understand. So this file, if you've never seen it before, these are the users that exist on this system. So there's a root user, there's a nobody user. There are some users that start with underscores because they are for like system services. There's a Dave user, and I've installed my own Nagios user. There's also an underscore Nagios. Not sure why there's two. Why is Mosquito even on here? I don't know. I haven't logged into this machine in a while. I don't do much. This is just my like Linux testbed machine. So there's probably some weird stuff on here. But as you can see, we have the Dave user, we have root, we have nobody. This file has a format to it. As you can see, it's separated by colons. And instead of me telling you what it is, we can actually just get the man page for it. So we can man password, and password is a command. So we pulled up the section 1 for it, change user password. But instead of pulling up the man page for this, we can pull up, I'm going to do this off the top of my head, man 5? Oh, I'm a legend. Okay, we can pull up section 5 of the password, and this is on Linux, this describes file formats and conversions. So this is super useful because this tells us what the etc password file actually looks like. So you can see it contains one line for each user account with 7 fields delimited by colons. These fields are name, optional encrypted password. You usually won't find a password here. You'll find that in the etc shadow file instead, which will have more lockdown permissions on it. The numerical ID, the numerical group ID, the username or comment field. So this is just like a user specified field. The home directory and an optional user command interpreter. So this would be like their shell. So with that knowledge, knowing all the fields we have, we can cat etc password, and we can see all this stuff here. And then we could pipe that to cut, of course, delimit it on colons and grab the first field. And there we go. There are all the users on here. Of course, if you didn't want to use cat for whatever reason, cut also takes the name of the file. You could put etc password here, and then you cut out a pipe, you cut out a subshell, you cut out the usage of cat. For this example where I'm teaching you, I like to put it at the beginning because then I can make quick modifications here without having to backspace over the entire file. So if I were to put this in a script, I'd probably approach this way differently, but I wouldn't be doing cat pipe into something if I were doing it in the script. But on an interactive example like this, yeah, I'm definitely doing it this way. So there's our user accounts. There's our encrypted password. As you can see, no one has it set there. We're all using etc shadow. There are the UIDs, the user IDs, the numeric user ID. So actually, let's go ahead and grab field 1, 3. So we can see, and let's grep for Dave. That's me. So we can see Dave has UID 1000. Who am I? Dave ID. This is my UID 1000. My GID is 1001. And these are the groups I'm in, the supplementary groups. So I'm just using this command to show what this is, and then to show that etc password also mirrors that. So if I were to cut for fields, what is it? Fields 1, 3, and 4, that should be my username, my ID, and my GID. So it should be Dave : it should be Dave space 1000 space 1001. There we go. That's awesome. Not space, colon, sorry. It uses colon because it still uses the same delimiter character. That makes sense. So that's awesome. What else was there? There was 5. Was 5 a comment? Yeah, 5 is a comment that's optional. As you can see, it has my full name here. That's awesome. This is just like human readable string. So I could look at this as a system administrator and try to understand. I could put a useful note for myself, like what this user is for. 6 should be the home directory. So as you can see, my home directory is here. Some of these are set to var empty. They don't have one. Nobody's literally set to dev null. That's pretty awesome. And then the last thing we can do is we can get the shell with 7. I'm going to also print the username, just make it easier to see. So of course, I'm using the bash shell. Root set to bash. Nobody, set to bin false. You might see some bin false. You'll see some sbin no login. These are ways of denying a user a shell. So like the user Nagios can't get shell access. I'd have to look in to see why some are no login and why some are bin false. I think they effectively work the same way. I don't know if there's differences when it comes to logging in on an actual console. But long story short, root has bin bash and Dave has bin bash. That is what my shell is. And you can parse etc password using this tool, which is super awesome. Now here's the thing. If I wanted to make modifications to this file, I can absolutely vim this file. You probably shouldn't. I've absolutely done it in the past. Of course, most system administrators I know have definitely done this. You shouldn't. There are tools to modify it. There's user mod, which can modify certain things about a user. It could probably change their shell. CHSH to change a user shell. If I run this, it'll ask me what I want my new shell to be. So you won't ever really need to modify this file, but I want to show you just using this file as an example. Not going to make any modifications, but I just want to show you some of these tools using this file because it is really cool. So we cat etc password. Let's go ahead and pipe grep for Dave, and then let's grab these two fields out of it. That's awesome. All right, so what if I wanted to change the username? Again, I'm not actually going to change anyone's username on the system, but what if instead of Dave, I wanted to say something else? Well, we know that I can change A to O, and now I can say Dove, but then Dove executes bin bosh, so that's not great. This is not a bosh course, this is a bash course. So stupid, I'm so sorry. But what I could do is if I wanted to change Dave to something else, there's an easier way than doing DAVE here and just changing it to XXXX because that'll change every instance of D, A, V, and E. It treats them as individual characters. What I can do is I can edit this stream. I can use a stream editor. I can use sed, my stream editor. So with sed, it takes a very specific notation. You may have seen this before. I'm going to put the whole thing in quotes. You start with S, and then you typically put a character here. It's usually a slash, but we'll talk about that. I'll put a slash here. The thing I'm looking for, Dave, slash the thing I want to replace it with. Let's change it to buddy. Notice it doesn't have to be the same amount of characters. Slash, and then close that quote. So it runs off my terminal. As you can see, it's going to get a little bit gnarly here. But I run this, and now buddy has bin bash here. Again, I didn't actually make any changes. Nothing changed on my file system. This is just changing what prints to the screen. So I'm not making any system changes here. I'm just illustrating a concept. Using sed, we can do basic find and replace. But sed, of course, very powerful. Instead of changing D-A-V-E, I could do D, any character, E. So it supports regex pattern matching effectively. There are different versions of sed. Some sed supports a very limited version of regex. Some will have like a more Perl compatible regex. If you don't know what I'm talking about, go down the rabbit hole of looking into regex. What I'm saying is regex. Some people get upset with me. They want me to say regex. I'm never going to say that. But it's short for regular expressions. That's what I'm saying here. These are what goes in here on some versions of sed. So sed is one of those tools. It's going to be on all your systems, but it might work slightly differently. Right now I'm on Linux, so I'm using the GNU variant of sed. On my Mac, the sed over there works differently. That's why, again, later in this course, I'm going to talk about some things where we won't really even need sed or tr or cut or anything. We're going to do all of it with bash. But for now, I think these are important tools to use. Like, these are important tools to know about. They're great. I still use all these on a daily basis. They're so quick and easy to just make quick changes to files. They're great. They're wonderful tools. So we have this. You might also see some people will do -E for expression. The thing here that's nice about this is I can do another -E. So now I could change bash for, let's say, I don't know, fish. Maybe I wanted to use the fish shell. So now we can do multiple expressions. So buddy is using bin fish as an example. Sed is super great, especially if I wanted to change my shell. Now you may notice there's a problem. My shell is bin bash, but it also uses slash characters. So if I want to change bin bash to, I don't know, bin fish, that's way too many slashes. The nice thing about sed is I don't have to use a slash. Slash is convention. I can change this. You could change it to a pipe character. You could change it to a pound sign. I've seen people use both. I'm quite partial to the pound sign or the octothorpe. If you think of pound sign, you think of like money. I'm American, so in my mind, the pound sign is just the little octothorpe guy there, the hash mark, whatever that is. So we can use that. We can put bin bash here, bin fish here. Sorry, that's kind of hard to read. I'm going to go ahead and condense these two lines. Let's go ahead and grep Dave out of etc password, just so we have less runoff on the screen. There we go. So you can see bin bash here, and then this little pound sign, bin fish, and then the little pound sign. You run that, and then it goes ahead and makes that change. So that's something cool about sed. You can just swap out that delimiter character. It doesn't matter too much. So now I want to talk about another tool. I'm going to talk about awk. Awk is amazing. It's incredible. I love it. I took some time, maybe 10 years ago, to really study and learn awk, and it has been one of the most beneficial things I have done. I would recommend you do it. I am going to give you the world's quickest crash course in it. I am going to touch on 0.01% of what awk can do, but I'm going to talk about basically the ways you'll probably see it most often in the wild. Take some time, learn awk. I could make a whole 10-hour course on awk. It is so powerful, the things you can do. So hey, if this course is successful, maybe I will. But let's focus on bash first. I'm just going to give you a quick little deep dive into awk. So we have this whole thing right here where we have grep Dave out of Etsy password. We cut for the fields we want, blah, 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 blah. We can use awk. So let's keep it simple. Let's do our cat Etsy password. And awk, of course, can read in from standard input. It can also read in a file. If I were putting this in an awk script, you can actually make awk scripts. Yeah, I would just pass in the file. I wouldn't pass it over standard in, but we're illustrating a concept here. So with awk is its own language. So I can open a curly brace, and this will run for every line of input. If I print $0, remember, this is all in awk. $0 is not a bash thing in this context. Because it's in single quotes, this is all being passed to the awk program. $0 is just the line in its entirety. $1 is the first field. Notice how it broke the field? It broke the field on white space. By default, awk breaks it on white space. If I want to modify it, I have to give it to an argument, -F, and then the field that I want to use as the delimiter. So in this case, I'm going to use the colon. So now when I do this, there's the first field. There's the second field. There's the seventh field, which is the user shell. So now, let's say I wanted to get just the user Dave out of it. I printed $1, I could print $1, $7, and now we have, notice there's no space or anything. You can put a comma here, and we can get a space between the two of them. There is also a printf notation built into awk. So I could say %s has shell %s new line and put these as arguments, semicolon, and run it. That's a lot. I won't keep it because it makes the command get really gnarly. I just want to show that awk has a lot of things built in. Let's go back to this notation. We have $1 and $7. Let's say we only want Dave. Of course, we could grep Dave and do that, and that works just fine. There's nothing wrong with that. But we're here. Let's use awk. We can go here, and at the beginning, we can put a conditional here. So we could just say $1 equal Dave. Yeah, that's it. You run this. I'm going to get rid of the grep. As you can see, we pipe it into awk. We have $1 equals Dave. So if $1 is equal to Dave, then we will run this line here. There you go. All in awk. We can get rid of a lot of that pipeline, the cat, the grep, the tr, all that stuff. You can get rid of all that just by doing this. Of course, if you wanted to, you can even get rid of the cat. We could replace this with this syntax. Do you remember this? We're going to read in from the file as standard input. And now awk's is reading standard in, but no cat was being forked and exec. So you can get these scripts to be very small and very elegant. Now we could do something different. Instead of just getting Dave, let's go ahead and get all the shells. So $7 is the shell. And there we go. You can see there's a lot of shells here. What we could do now is I will show you some other commands. You could do all of what I'm about to do in awk, but again, it's just a crash course. I can't dive into all the specifics of awk, really. I love awk, like I really do. I'm so, oh man. If I were to ever get off my bash shtick, I'd be jumping on awk and making content about that because it's just so powerful. Now that we have this, we can pipe this to sort. Sort is a new command I haven't taught you guys, but guess what it does? Sorts the input. Very simple. That's what it does. It sorts it. It's amazing. Now I could pipe this to unique. Unique is another command. Unique will just leave you with the unique outputs. Your data has to be sorted first, so you have to pipe it to sort and then pipe it to unique. So these are the only ones that were unique. As you can see, bash was twice, false was twice, and no long it was some number of times. Luckily, unique takes a -c. So here is a frequency count. This is how to do a very simple, a very basic frequency count by piping to sort and piping to unique -c. If you can get your data down to just a list of things, you could pipe it to sort and unique -c, and you can see how many times each one showed up in that input stream of data. Super awesome. Super, like actually super awesome. Super useful. And there's another thing I want to show. Does Linux? Oh, my Linux machine doesn't have user shared dict word. So I'm going to back out of here, Control D, end my SSH session. Now I'm back on my Mac. And let's go ahead and cat user share dict words. And we've done this before. We grepped -c for Dave, -c for count. So 11 lines contained Dave in it. That's great. But there is another command I want you to be aware of, and it's called word count. Word count is incredibly useful, like incredibly useful, because I can run word count minus L for lines and I get the same information. I get 11 here, I get 11 here. So word count is super useful for being able to count lines. It also counts words. So keep that in mind, because let's do something different. Let's get crazy here. Let's do a man ls, and here is the man page for ls, right? Well, I could do man ls pipe grep for Dave, and you know, it's really sad that my name doesn't show up in the ls man page. How upsetting is that? Let's look for a word that will be there. How about the word file? I bet the ls man page uses the word file somewhere. Hey, there's a lot of lines there. That's awesome. Let's go ahead and pipe it to word count minus L. There are 70 lines there. 70 lines in the man page for ls contain the word file somewhere in them. In fact, of those lines, we can do -w. There are 738 words. And of those words, there are 5,100 characters. So word count -w for words, -c for characters, or on its own, you get all three. There were 70 lines. Of those 70 lines, there were 738 words, and of those 738 words, there were 53 characters. This is also, you should be careful about this. This is not like Unicode aware. This is not like emoji aware. This is just counting bytes. So WC-C is actually just super useful for counting raw bytes. So something to keep in mind, something useful. But yeah, these tools are really great. When used in conjunction with each other, when passed over pipelines, like I want you to see just how powerful these tools can be. Of course, the later parts of this course, I'm going to be showing you how to avoid a bunch of these tools to do things faster by using the bash built-ins. But that's the point. I want to start from the very beginning and kind of work my way forward with all of this stuff. And I want to intersperse commands that have been around forever with some syntax that's brand new, and just try to show how this stuff evolves over time and give you a little bit of the history of it, and also bring forward the useful stuff. Like, we're talking about tools written in the 70s and the 80s, and they're still useful today. Like, they're awesome. Like, many of them are just feature complete, and that's an amazing, feature complete is one of the best stamps of approval you could give a piece of software ever. Like, I will stand by that.